Hey guys, welcome to the Level 3 Calculus Integration paper from 2022. If this is the first time you're joining us, where have you been for the last 3 years? Anyway, so the way this video works is that I go through each question, let you guys know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go by yourself with the answers, and then unpause the video just to see how I go about with the question. So without further ado, let's get started. Alright guys, so with question 1, we've got a straightforward integration question. So integral of 4 over x, we can write that as 4 ln of x. And sec squared x, we know that integration of sec squared x is actually tan x. So that's going to be tan x right there. And of course, don't forget your plus c for this question. And once you do that, it's pretty much straightforward achieved for that. This is actually not a bad question to start with, because when I think about all the achieved questions that integration starts with, this is actually quite a nice and straightforward easy achieved question. But they don't actually mention anything in the answer schedule about penalties for plus c, but I always get into the habit of, like, when you're doing integration paper, just get into the habit of putting that plus c. Okay, so we go to question 1b. With 1b, we've got graph, it's symmetrical. The area of the shaded region is actually given. Now, they're asking you to find the area between 3 and -3. So that's under the curve, right? So basically you've got this area, you've also got this part here. What I'm going to do is I'm going to slightly color it in different ways so that you guys can kind of get the idea. So we've got this part, we've got this part, and then finally we have this part here. Now what we're going to do is, because it's actually symmetrical about the y-axis, we know that this green area is going to be 4.4. And we are also going to know that the pink area is going to be 1.2. So that's something first that we've got to remember. So we've got 4.4 and 1.2. Now, here's the thing though. You've actually got area above the x-axis, and then you've got area below the x-axis as well. Now, the area above the x-axis, that is 4.4 plus 4.4, which equals to 8.8. So, and then below it, you've actually got 1.2 plus 1.2, which equals to 2.4. But remember that it's actually below the x-axis, and because it's below the x-axis, it's actually a negative value. And so when we actually do 8.8 take away 2.4, you actually end up with 6.4. And you pretty much need this for your achieved grade for this question. Alright guys, so with question 1c, remember that we actually can't integrate sine squared x, and because we can't actually integrate sine squared x, we need to replace it with, where is sine squared x? We have to go down to the double angle, and then we've got 2 sine squared a, this particular formula here, the one that says cos 2a equals 1 minus sine squared a. So I'm going to copy that equation out first. So I've got cos 2a equals 1 minus 2 sine squared a. Alright, now once I've copied that equation down, what I now need to do is I now need to rewrite sine squared 2x in terms of cos 2a. So if I was to do this, I'm going to get, if I rearrange this, I'm going to get 2 sine squared a equals 1 minus cos 2a. And of course, then I can say sine squared a equals 1 minus cos 2a over 2. I've not integrated this question at all. I'm still rearranging it. And finally, now I can do is I can substitute the 2x as a. And if I was to do that, I'm going to get sine squared 2x is equal to 1 minus cos 2 times 2x over 2. And of course this could be written as 1 minus cos 4x over 2. And one more little step, half minus cos 4x over 2. Now I've not actually solved this question at all. In fact, the only thing I've done is I've just rearranged it so I'm actually able to integrate it. So now I'm going to go into the question and I'm looking for between pi over 4 and 0. And instead of sine squared 2x, I am going to write half minus cos 4x over 2 dx. And at this point now I can start integrating it. So when I integrate half, I'm going to get x over 2 minus integration of cos 4x is sine 4x over 2. But of course remember, you've got to divide by the differentiation of whatever is inside this red bracket. So the differentiation of 4x is 4. So I've got to divide this by 4. So I've got to remember, I've got to put a little multiplication sign there. And that's basically it. And this is between pi over 4 and 0. So looking at it further, I'm going to go x over 2 minus sine 4x over 8 is pi over 4 to pi over 4 and 0. Now here's a little kind of time-saving tip that I have when it comes to the marking of this paper, right? Like what you can do is you can actually do this question on the graphics calculator, but to the way I do it is like I kind of do these steps and I even substitute it. So I actually go because x is pi over 4 first, I go pi over 4 over 2 minus sine 4 times pi over 4 over 8, and the whole thing is minus 0 over 2 minus sine times 4 times 0 over 8. Now it's incredibly easy to put something wrong in the calculator when you're typing this long equation, and this is why it's kind of important that when it comes to doing these kinds of problems, what you can actually do is straight away go into we're going to do menu, we're going to go run, and we've got integral. So I think it's been a while since I did this, but there we go, we've got option and integral. So to get there we go option, calculus, which is F4, integral sine, which is F4, and we're going to write sine 2x squared. So we're going to put sine 2x in a bracket, and then that is going to be squared. So if I counted my brackets, that's 1, 2, yep, comma, and then you write your 0, comma, pi over 4. And so what I'm getting here is 0.3939263, whatever, right? So I can actually write this as my answer. So I'm going to put down 0.0393. Now here's the thing, if you're really good with your pi, like you understand that it's going to be because this answer is already here, right, and you know that you had a pi in your answer, what you could actually do is you could actually go shift pi and you could go divided by the answer, and it actually gives you 8. So the trick is, like, you can actually write 0.393, or you could write your answer as pi over 8. I'm going to show you guys the answer schedule here. In the answer schedule, as you guys can see, their answer that they give is pi over 8. But if you look at the merit column, they actually say accept 0.393 as well. So theoretically, you could actually do this question up to 1, 2, 3, up to the 4th line, and instead of actually substituting that big equation in your calculator, you just use the integral function and then get the 0.393, because basically that 0.393 is going to give you a merit grade. And as for achieved, you're looking at somewhere here when you actually integrate it correctly as your achieved grade. So with question 1D, what we've got here is we've been given an area and we've got to try and figure out what the value of k is. So first up, we're going to kind of write the question out. So what we've got here is integral between k to 1, 4 over square root of 3x minus 2 is equal, oh wow, is equal to 8. Let's power that in, that's not good. Hang on, let me just pause this. We're back in power, yep. All right, so we've got this equation between k to 1, and then this is all equal to 8. Not going to forget the dx there. Before we actually integrate this, we need to get rid of the square root symbol by bringing it to the numerator. Because remember, I'm going to do this extra step here. When you have square root, it's the same thing as saying 3x minus 2 to the power of half equals to 8, and k to the power of k and 1, and we're going to bring that 3x minus 2 to the power of negative half to the numerator, and this is all equal to 8. We keep forgetting that dx. Okay, so now that we've actually brought it to the numerator, we can start integrating this. So like with this one, you know, we've just got to be kind of careful with it because there's a lot happening here. I'm going to slowly start doing this. So we've got 4 3x minus 2. The negative half, we have to add 1 to the power. So that's going to be plus 1. But instead of 1, I'm just going to write that as 2 over 2. So it's easy for me to add. And I've also got to divide by the new power. So the new power is actually negative half plus 2 over 2. Plus I've also got to divide by whatever is the differentiation of inside the bracket. So lots happening here. So the pink part is my new power, dividing it by the new power, and then multiplying it with the differentiation of the bracket. That is from the yellow bracket. The 3 is from the yellow bracket. So now if you do have a easier way of doing this, by all means go for it, but that's just kind of the way I do it. So anyway, carrying on, we've got 4 3x minus 2 to the power of 1 over 2 divided by, we're going to get 1 over 2 as the pink bracket, the pink stuff that's highlighted. 1 over 2 times 3 is 3 over 2. All of this is between k to 1 equals to 8. Then 3 over 2 is the same thing as taking 4 3x minus 2 to the power of half divided by 3. But now the 2 comes to the numerator, so we've actually got 8 in the numerator. Between k and 1 equals to 8. Sorry, I know I'm doing this the long way, but I just want to make sure that you guys understand all the steps. And I know some people can actually do this in like a couple of steps. They're just there, right there. So this is pretty much how we get here. Now once we get to this part, remember we need to substitute the k value. So we're going to get 8 3k minus 2 to the power of half over 3 minus 8 times 3 times 1 minus 2 to the power of half over 3 is equal to 8. So with that in mind, it's a matter of just rearranging everything, and I'm guessing I'm probably going to make a mistake somewhere, but let's see how I do this. The first thing I'm going to do is I'm going to get rid of that 3 to the other side. Oh, it's actually 8 over 3, because 8 over 3 is a common factor. I'm just going to take that out, which means I'm going to get 3k minus 2 to the power of half minus 3 times 1 is 3, 3 minus 2 is 1, that's going to be 1 to the power of half, which is just 1, equals to 8, which means I'm going to get 3k minus 2 to the power of half minus 1 equals 8 times 3 over 8, Nearly getting there, folks. So 3k minus 2 to the power of half minus 1 is equal to 3. And then 3k minus 2. Now the half is just square root. And the negative 1 goes to the opposite side because then it becomes plus 1. Square root of 3k minus 2 is equal to 4. Square both sides. 3k minus 2 is equal to 16. And then we're going to get 3k is equal to 16 plus 2. 3k is equal to 18. K is equal to 18 over 3. K is equal to 6. Now, pretty long question for a merit, but that's pretty much what we're looking at. For achieved, we are looking at that line right there. That's what you're looking at for achieved. Yeah, it's a lot of working for this question. Okay, so with question 1e, what we've got to do is, we've got to actually figure out what this area under the curve, exact area is. Now, the problem is we actually don't know what this value is. Now, this value, the left-hand side of the limit, we know it's 0, but the right-hand side, we don't know what it is. And having a look at the answer schedule, right? Like, look, they've actually got working out for how to. This part here, they're actually showing this working out for how to find that x value is, which equals to ln of 5. Now, if you look at the answer schedule itself, right, there is no kind of grades for this part of the question. Sorry, I know it's not highlighting as well as I'd like. No, it's doing something stupid, but you get what I'm trying to say. This part of the question, there's actually no grades at all anywhere here, because that's just finding the intersection of those two lines. So I'm wondering, can I just use my graphics calculator to figure it out? Let's just try it out to see if it actually works. So I'm going to go into graph mode. I'm going to type in my first equation, which is e of x, wherever that is, shift to e of x. And that's going to be e of x squared. Yeah, that's all good. My second equation is 3 times e of x. And then I've got plus 10. So I've drawn both of these graphs. Now, obviously, I can't actually see these points. But if I go gsolve and see if I can find the intersection, is it going to work? I get 1.609. I see the problem. The problem is that it's actually going to give me a decimal point. And I think ln of 5 just would work. Okay, so see how I'm getting 1.69? But when I go to the answer schedule, they actually use ln of 5. And I think using ln of 5, the calculations become definitely a bit easier. But let me just go check if ln of 5 is the same as 1.6 something. No, exit. Menu 1, ln of 5 is at 1.6 something. Yeah, that is 1.609. Okay, so if that's the case, I guess I got to show you guys how to do that long method of how to actually solve it. So let's might as well show it since we're here. Okay, so what we're going to do is we've actually got e to the power of x squared is equal to 3ex plus 10, because we're going to put those two equations together and we're going to try and figure out what that x value is, where they actually meet. So the first thing I'm going to do is, and I guess this is the kind of like the annoying part of this question, is that you actually need to recognize you're dealing with that, the weird quadratic equation that you used to do in level 2, where you had like you do like a substitution, like u squared, like u equals to something. Let me show you guys what I mean by it. Like if I actually take u, and if I put u as e to the power of x, then I'm going to end up with u squared is equal to 3u plus 10. Now I can have, what I have got here is actually a quadratic. So I can rewrite this as u squared minus 3u minus 10 is equal to 0. So then I can factorize this quadratic. So I've got u minus 5, u plus 2 is equal to 0. Then I can say that u minus 5 is equal to 0, or u plus 2 is equal to 0. So u is equal to minus 2, or u is equal to positive 5. And because u is equal to e of x, we can say that e of x is equal to 5, or e of x is equal to negative 2. Now, unfortunately, with exponential curves, they don't actually go to negative side at all, so we can actually ignore this, and here we can actually say that x is equal to ln of 5. So I've figured out what this value is, which is actually ln of 5. Now, I know some of you might be asking this question: what if I use that 1.609? Will I get it right? Will I get it wrong? I'm actually not sure, because in the answer schedule they've actually kept everything at ln of 5 and there's no decimal points anywhere. My initial guess is it should be okay, but I don't want to be quoted on that, so I probably will stick to the ln of 5 method. Okay, the next thing is trying to actually figure out which curve is actually at the top. Now it's kind of not, I wouldn't call it obvious, but because this graph has got plus 10 as its y-intercept, we're going to assume that this here is going to be 3ex plus 10, and then the bottom curve is e of x squared. So our equation that we're going to have is between ln of 5 and 0. We're going to do 3ex plus 10 minus, so remember that thing that we do top minus bottom for the area between two curves? That's what we're doing here. Top minus bottom, e of x squared dx. All right, so next thing is, that is pretty much our setup of our equation. Correct interval. Okay, so that this part right here gets you an achieved. So I might as well just give the grade as I go along. Then I'm going to integrate it, but before I integrate it, I want to make sure that this is a nice equation to work with. Now, what do I mean by that? Is e of x squared is just e to the power of 2x dx. So now I'm going to integrate this. So I'm going to get 3ex, because when I integrate ex, I'm just going to get that 1, so I don't really need to worry about it. When I integrate 10, I'm going to get 10x. And then when I integrate e to the power of 2x, I write everything as it is, and I've got to divide by the differentiation of the power. In this case, it's going to be 2. And the limits for this is between ln of 5 and 0. Now, correct integration is actually going to get you a merit, which is here. And remember what I said to you guys before in this, I think it was question C or D that we did, where we need to find the area between two curves. Well, theoretically, we can actually put this in the graphics calculator and get our answer. But what I am going to do, though, because it's an excellence question, I am simply going to put my little values here. So I'm going to go 3e to the power of ln of 5 plus 10 times ln of 5 minus e to the power of 2 times ln of 5 divided by 2, and the whole thing minus 3e0 plus 10 times 0 minus e to the power of 2 times 0 over 2. And of course, I'm not actually going to solve this, right? I mean, it's just going to take too long to try and put this all in a calculator. But what I am going to do is I'm going to do that very first line before I integrate it. I'm going to put that in the calculator. So I'm going to go into option, calc, integral, and what is my equation? I've got 3ex, so shift e to the power of x, plus 10 minus e to the power of 2x. And I'm going to put my limits, which is 0, and it's also between 0 and ln of 5. Now, I just realized the problem with this, but it's all right. So I'm getting that 16.09 can call it 16.094 if I want to. Yeah, see, like I think it'll be okay, guys, to actually put this decimal answer, because I'm trying to think about this, right? If you actually substitute ln of 5 in your calculator, at some point you're going to get a decimal. And I know the answer here has actually given, the answer is actually given in 10 ln of 5. I guess it's because things kind of just work out. If you have a look at it here, guys, the answer schedule. So in the answer schedule, they actually kind of simplify it eventually to 10 ln of 5. Now I guess I'll show you guys how to do that as well, so just so that we can kind of see what's happening here. So 3e ln of 5 could be written as e and ln just kind of cancels out each other, so you're going to get 3 times 5 plus 10 ln of 5. Now here you've got e times 2 ln of 5 over 2. That's just, how do we put this? Oh, I see what they've done. Oh man, this is too much work for you guys. I mean, I know how they get 12.5, because basically this thing here, they rewrite it as e to the power of ln of 5 squared over 2, and then they get e to the power ln 25 over 2. So e and ln cancel out, which is 25 over 2, which actually gives 12.5. So they go minus 12.5 minus, now 3e is 0 is just 3, 10 cancels out because it's a 0, and then you're going to get 3 minus a half, and that's how you get that 2.5 minus 2.5, and then eventually all you're left over with is just 10 ln of 5, which is the same as 16.094. So I'm actually thinking for this question, you might actually be all right just not using that ln of 5. You might be okay using that 1.609, because at the end of the day, your answer eventually comes to 16.094 anyway. Bit of an annoying excellence question, just because of all that little manipulation that you need to do. But other than that, that final answer is actually going to get you an E8 or E7 with minor errors. So with question 2a, we know this is going to be a nice and easy achieved question. But before we actually start with this question, we want to make sure that we get rid of that square root symbol. So we want to replace that with x to the power of half. And then once we do that, then the next part is integrating it. All right, e to the power of 3x. When we integrate it, we're going to get exactly e to the power of 3x, and we're going to divide by the power, the differentiation of the power, which in this case is 3 minus x to the power of a half plus 1, and divided by the new power, which is also half plus 1, and of course don't forget your plus c. Now some people ask this question like, hey, can I actually leave the answer like this? Theoretically you can, because all you got to do is just make sure you put a bracket around these two things and you're done. You don't really need to simplify it. You can simplify it if you want to, but that's pretty much enough for this question. So that is going to get you an achieved. And you know what, there's always someone that goes, yeah, but tell me what the final answer is. So the final answer is this: e to the power of 3x over 3 minus x to the power of 3 over 2 over 3 over 2 plus c. And one final step is bring that 2 from the denominator to the numerator, and this is what our other final answer could be. With the next question, we've got find the value of k. It's 2 over root x. So what we've got is we're going to put this up here, k to 1. Instead of root x, we're going to get rid of that root and we're going to put it with x to the power of half. Dx is equal to 8. And then we're going to bring the x to the power of half to the numerator. So we're going to get 2x to the power of negative half. Dx is equal to 8. And then we need to integrate this. So we're going to get 2x negative half plus 1. And of course divided by negative half plus 1 as well. And our two limits are k and 1, and this is equal to 8. Now, I'm not gonna lie, I hate this question. I hate this question because it's like there's just too many substitutions for an achieved question. It's just annoying. But anyway, we've got what is it? We've got half in the numerator, so we're gonna get 2x to the power of half over half, and that's between k and 1 equals to 8. Next up, I'm going to bring that half to the numerator, so it's going to become 4x to the power of half between k and 1 is equal to 8. So I've got 4k to the power of half minus 4 times 1 to the power of half is equal to 8. So 4k to the power of half minus 4 is equal to 8, and 4k half is equal to 8 plus 4. 4k to the power of half is equal to 12. K to the power of half equals 12 over 4. K to the power of half is equal to 3. Therefore, k is equal to 3 squared, which equals to 9. Like I told you, it's an extremely annoying question for an achieved, that there's so much kind of working out to actually get to that final answer. And it's what's worse is that this type of achieved question, I'm looking at it. It took me like almost 30-40 seconds to actually work this question out, and it's only worth an achieved. And one tiny mistake, one little mistake somewhere, and basically I'm not going to get an achieved grade for this question. Frustrating, long, but it is what it is. Okay, so question C, what we've got is consider a differential equation, blah, 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 given that y, blah, blah. Okay. So when it comes to differential equations, all we really have to do is just bring all the y's to one side, bring all the x's to the other side, and we integrate. So we've got dy dx is equal to 1 over 3y squared x minus 1. So I'm going to cross multiply here and get rid of the 3y squared to this side, which means I'm going to have 1 over x minus 1 dx. I'm going to bring the dx to the right hand side. Now I've got to integrate both sides. When I integrate 3y squared, I'm going to get 3y, 2 plus 1 is 3, divided by the new power, which is 3. Let's get that right. Equals 1 over x minus 1. Integral of that is just ln of x minus 1. I don't have to worry about it dividing anything because differentiation of x is just 1. But I do need the plus c here. And I think getting up to here is going to get you an achieved grade. As for the question itself, what we've got here is y cubed is equal to ln of x minus 1 plus c. Now it does say given that y equals -1 when x equals to 2. So we've got to substitute that to figure out what c is. So we're going to get -1 cubed equals ln of 2 minus 1 plus c. So we're going to get -1 equals, now ln of 1 is just 0 plus c, which means we're going to get c is equal to -1. So my equation is going to be y cubed equals ln of x minus 1 minus 1. So now they want to find the values of x which give a y value of 1. So I need to put when y is equal to 1, what is x equal to? So 1 cubed equals ln of x minus 1 minus 1. I'm going to get 1 equals ln of x minus 1 minus 1. -1 comes to the other side, becomes positive 1, and we're going to get 2 is equal to ln of x minus 1. Now here's the thing, you don't actually need to how do I say it, you can just put e of both of these things. So you can actually go e of 2 equals e of ln of x minus 1. So we're going to get e of 2 equals x minus 1, and then x is equal to e of 2 plus 1. And then that becomes your merit grade. Now you could actually write this as a decimal point. I think it's 8.389, but theoretically you can just also just do it up to here and just leave this question as is. So kinematics, we got acceleration that's been given to us, so I'm going to write that down straight away. Acceleration of t is 0.9 e of 0.3 t. Blah blah blah. Object has a velocity of 10 after 2 seconds, so v of 2 equals to 10, and we are asked to figure out how far did the object travel during the 5th second of its motion, not after 5 seconds, but the 5th second. So we want to know between 4 to 5, because that is the 5th second. So yeah, we're good to go. So from acceleration to velocity, we need to actually integrate the acceleration formula. So we need to accelerate between integrate between 0.9 e 0.3 t dt. When we integrate this, we're going to get 0.9 e of 0.3 t divided by the differentiation of whatever the power is, which in this case is 0.3, and of course don't forget the plus c. So this is what the velocity function is. So I can do one step further and I can end up with 3e 0.3 t plus c. Now I do know that when the time is 2 seconds, velocity is equal to 10. So v of 2 is equal to 10, which means 10 is equal to 3e 0.3 times 2 plus c. Unfortunately guys, like, let's face it, we're not going to get like a nice number here. We're going to have to actually work this c value out. So into my calculator I go. I've got 10 minus e, no, 3 times e to the power of 0.6, and this is what my c value is, which is 4.534. Yeah, let's go 4.534. So my velocity function is equal to 3e 0.3 t plus 4.534. Now I need to figure out what the how much the object traveled in the 5th second. So that means I need to look at it between 5 and 4. Now you could actually find what the distance formula is and then find s of 5 and subtract it with s of 4. That's kind of pretty much what we're doing here, except we're doing this all in one shot. So 4.534 dt. So when I integrate this, I'm going to get 3e 0.3 t divided by the differentiation of the power, which is 0.3, plus 4.534 t, and this is between 5 and 4. And remember what we talked about earlier. Once you get to this point, what you could do is just substitute it, but then use the calculator to try and solve this. So I'm just going to go 3e 0.3 to the power of 5 divided by 0.3 plus 4.534 times 5 minus, and I'm going to put the 3e 0.3 to the times 4 divided by 0.3 plus 4.534 times 4. Now, as I said to you guys before, putting this in the graphics calculator, the chances of you making a mistake are extremely high. Like, I mean, I make mistakes with this, so don't be like, oh no, I can't even put a bunch of numbers in a calculator. Because trust me, when you have that many things happening there, it's just incredibly easy to actually make a mistake. But instead, what we're going to do is we're going to go into option, calc, integral, and we're going to enter the equation as it is. So 3e to the power of 0.3x plus 4.534, and our limits are going to be 4 and 5. Okay, and what I'm getting is 16.1497 if you want. So remember that with using the graphics calculator, you can actually use the graphics calculator to work out these types of answers, but you have to show the integral, and it's a really safe thing to actually just to show the substitution so that you can show the marker that, hey, I know what I'm doing, but I'm also not going to waste my time by putting this extremely long equation in a calculator where I have a very high chance of making a mistake. Now, if I show you guys the answer schedule itself, as you guys can see, that's pretty much what they do there. They kind of do the substitution, and they've substituted those values in there, and then they've just put in the final answer. In fact, I think that shouldn't have an S. It should probably should have just 4. But their final answer is 16.1497. So that 16.1497 is actually going to get you a merit. So we've got a merit for the final answer. Correct equation for V is actually an achieved. So you still need to find that C value to get the full achieved grade itself. Okay, so with question 2E, we've got a barrel that's 150 high. So, well, full of oil. So we can say that when T equals to 0, the height is at 150. That's something that's worth actually remembering. And then what we're going to do is we've actually got dH over dt equals -1/4 square root of h minus 6 to the power of 3. So we've got a differential equation. So we're going to bring in the h to the left hand side. So that's going to become h minus 6 cubed equals -1/4 dt. Now we've got to do a bit of rearranging here. So the first step is getting rid of that square root. So we're going to get 1 over h minus 6, getting rid of that square root, and because it's a cube, we're going to get 3 over 2 dh equals -1/4 dt. And of course, we're going to bring that h minus 6 to the power of 3 over 2 to the numerator, which will make it -3 over 2 equals -1/4 dt. Okay, now that we've got everything set up, we are actually ready to integrate it. Because now we can go integral of this and integral of this. So we're going to get h minus 6 -3 over 2 plus 1. And we're going to divide by the new power, which is -3 over 2 plus 1. Differentiation of h is just 1, so we don't need to worry about dividing anything. And on this side, we're going to get -t over 4 plus c. So the next part is -3 over 2 plus 1 is -12. And if it's -12, we've actually got h minus 6 to the power of -12 divided by -12 equals -t over 4 plus c. Now, what I can do here is, I'm kind of going to carry on here. I'm going to bring that -12 to the right hand side, which means I'm going to get h minus 6 to the power of -12 is equal to -12 times -t over 4 plus c. Now, if you remember earlier, it's like if you have a constant and you multiply it with a number, you're still going to end up with a constant. So with that in mind, I've got h minus 6 to the power of -12 is equal to positive t over 8 plus constant. Because we don't know what that constant is. Right? Because we don't know what that is, it doesn't matter if you multiply it by 3 times the constant. A constant multiplied by another number is still a constant. So we're just going to leave that as a c. But we need to figure out what that c is. And so here we've got t is equal to 0, h is equal to 150. So if I go 150 take away 6 to the power of -12 is equal to 0 over 8 plus c. So what I end up with is c is 144 to the power of -12. It's the same thing as saying 1 over 144 to the power of half. And you know, square root of 144 is 12. So 1 over 12 is equal to c. So our equation that we have is h minus 6 to the power of negative half is equal to t over 8 plus 1 over 12. Now the question's asking for how long does it take for the oil to be 15 centimeters. So h is equal to 15, and they want to know what is t. So we've got 15 minus 6 to the power of negative half equals t over 8 plus 1 over 12. Now here we are going to get 9 to the power of negative half equals t over 8 plus 1 over 12. 9 to the power of negative half is just 1 over 9 to the power of half. I know I'm doing these extra steps here, guys, but it's just to show you guys how to get the that final answer. 9 to the power of half is 3, so 1 over 3 is equal to t over 8 plus 1 over 12. Then we can say t over 8 is equal to 1 over 3 minus 1 over 12. Kind of carrying on there, I'm going to get t over 8 is equal to 1 over 3 minus 1 over 12. It's late in the night and I don't want to do this. I'm lazy. Don't judge me. 1 divided by 3 minus 1 divided by 12. 0.25. So it's a quarter. So t is equal to 8 over 4. T is equal to 2. So grades wise, t equals to 2 is going to get you an excellence grade. Correct solution of DE gets you a merit. Correct solution of DE. So would that mean, I'm assuming here, here is where we're looking at a merit. Correct integral with respect to h. That's this line right here. That's what you're looking at for an achieved. All right, so question 3a, lovely integral question. We are going to do raise the power, so we've got 2x plus 5. We're going to increase the power, so 3 plus 1, 4. Divide by the new power, which is 3 plus 1. But also we need to multiply by the differentiation of whatever's inside the bracket there, which happens to be 2 in this case. And don't forget the plus c. So eventually the answer should be, what is it, 4 times 2, 8. Yeah, that's pretty much it. So we've got 2x plus 5 to the power of 4 divided by 8 plus c. And this question here is worth an achieved. Nice and simple one. And then we can move on to the next question. Oh, I hate the trapezium rule. I honestly do hate the trapezium rule. Why do I hate the trapezium rule? Because it's just so long. God. Okay. So with trapezium rule, guys, we're going to go into the answer schedule. Not answer schedule, formula sheet. And we're going to grab this particular formula. And notice how this is y0 and yn. And everything else is kind of in the middle. So we've got half h. H is b minus a over and blah, blah, blah. I'm going to have to write this equation down because I always forget it. I hate using it. BA is approximately half h. y0 plus yn plus 2 times y1, y2, all the way to yn minus 1. And then h is equal to b minus a over n, which is the number that we have. All right, so let's go into the main. Sorry, I just had to copy that equation down. Otherwise, I always stuff it up. So let's have a look. So we've got b and a, which happens to be 2 and 0, because the b value is there and the a value is there. So our h is going to equal 2 minus 0 divided by n. Now to figure out what n is, this is y0, y1, y2, y3, y4, and y5. So h is equal to 0.4. So we're going to get 0.4, is it half h? Yes, so half times h, and then we've got to do all of this. y0 is 3.6 plus y, the very last one is 3.2 plus 2 times 4.2 plus 4.8 plus 5.4 plus 4.5. I kid you not, no matter how many times I do these trapezium rule questions, I somehow always make a mistake somewhere, and I'm hoping today is not that day. So we've got 0.5 times 0.4, and in bracket I've got 3.6 plus 3.2 plus 2 times, what's in the other bracket, 4.2 plus 4.8 plus 5.4 plus 4.5. All right, come on, what's the answer here? Let's have a look. The answer was 8.92. Let me see if I'm going to get 8.92. Come on, come on, come on. Yes. Okay, I did it right. I have to be honest, like, of all the questions that I do in integration, the trapezium rule and the Simpson's rule question gives me the most amount of stress, because I have to be so careful with entering those values in, and it's just so frustrating. But you know, that is what trapezium rule is. Cool. So we go to question C next. I love this question. Why? Because I know that I can actually do this in calculator, but you've got to also write the proper integral formula. Now, I know that some people have like different ways of doing this, but like I do the long division method, right? So I actually go x minus 3, 4x minus 5. And what I do here is I multiply it by 4. So 4 times x is 4x. 4 times minus 3 is negative 12. And then I've got to subtract. So I got to go 4x minus 4x, which is 0. Negative 5 minus 12 is going to give me negative 5. It becomes plus 12 plus 7. So in other words, I could actually say that I'm going to get 8 and 5. 4x minus 5 divided by x minus 3 is equal to 4 plus the remainder, which happens to be 7, over x minus 3 dx. Now this is probably the most important step for this question, because once you get this part of the question, the rest of it is pretty much easy, because then you've got to integrate it. You're going to get 4x plus 7 ln of x minus 3, and this is between 8 and 5. Next, we're going to substitute the 8, 4 times 8, plus 7 ln of 8 minus 3, minus 4 times 5, plus 7 ln of 5 minus 3. And of course, remember what I said to you guys earlier in this paper. Like these types of questions, don't waste your time calculating it. Just go into integral, put the equation, which is 4x minus 5. So 4x minus 5 divided by, what have we got? X minus 3. And that's between 0 and, no, not 0, 5 and 8. And we've got 18.41. And like I said to you before, if I look at the answer schedule, 18.41 is the final answer, and that actually gives you a merit grade. And the part where you correct integral gets you an achieved. So the part that's important is actually this line here is what's going to get you an achieved grade for that. So question 3D, what we're going to have to do is we need to figure out what this x value is. So I'm going to call it x1. I'm going to call this x2. Those are the two values that I actually need to figure out first for solving this question. Now remember, when you're trying to find area between two curves, you can actually go between x1 and x2, and you go the top curve minus the bottom curve, dx. So what we have to do is we've actually got to figure out what those values are. Now, looking at this, we've got to put both of these equations equal to each other, because y is equal to x, and then the other equation is x plus cos x. When we do this, so all I've done here is, so there's my x plus cos x equation, and then my straight line, which is equal to y equals x. So I'm putting that equal to each other. X minus x is equal to cos x, and I'm going to get cos x is equal to 0. So x is actually equal to inverse cos of 0. Now what's really good for you guys to know is you don't want to be working with decimal points with this. Now if you think about a cos graph, I hope you guys have done this. I mean, if not, it's not a big deal. I mean, it just means that the cos graph would look like this, where this is 0, this is 90, this is 180, 270, and then 360. But ideally, you want to be working with pi. So this is going to be pi, and this is going to be pi over 2. So at pi over 2, sorry, that's actually 1 and this 0. So at pi over 2, cos of x is actually cos of pi over 2 is equal to 0. Now we've actually got 2 points here, so we're going to get pi over 2 on x1 and negative pi over 2 on the other side of it. So there's actually 2 values that we can actually see here. Okay, so with that in mind, we're ready to actually do this question. His Majesty is ready now. He's going to go for a bark, I'm assuming. So, integral of pi over 2, negative pi over 2. Now the top curve in this case is, of course, the x cos x. The bottom curve is the straight line, which is y is equal to x. So what we're going to do is we're going to go x plus cos x minus x dx. So the actual question itself, it's, you know, the integral part of it is actually not too bad, because then we're going to do integral between pi over 2 minus pi over 2 cos x dx. We're now going to integrate this, which means cos x integrated is sine x, and that's between pi over 2 and negative pi over 2. So we've got sine of pi over 2 minus sine of negative pi over 2. And that's pretty much it for this question, folks. So I'm going to do a bit of a lazy thing here. All right, what I'm going to do is I'm going to go shift pi divided by 2. So that's going to be my answer. And then I'm going to go sine of answer minus sine of negative 1 times the answer, just because I'm too lazy to actually type in pi over 2. There's my answer, 2. So grades wise, the final answer of 2 gets you a merit. Correct integral gets you an achieved, so achieved is right here when you get to sine x. So not bad for this question. I guess the trick part is just kind of finding those two x1 and x2 values. Now if you don't have pi over 2 and you decide to work with what is it, if I do shift cos of 0 on the calculator, I get 1.507. Now you could actually store that value, and if you'd actually done sine of answer, see, because I could do that part again and I'll still get 2. So yeah, you could actually store that value and kind of work with that as well. That's another way you could do it. Alright, so question 3E, what we've got is, as much as it looks complex in that first look, I kind of read through it straight away and I was like, hang on a minute, this is just a rectangle minus the area under the curve. That's all it is, because what you have is you've got a rectangle shape here. Then you've got area under the curve, which is the blue part here. And the pink part is what we're asked to actually find out. So long story short, we just got to go rectangle minus the blue curvy part, which actually equals the purple part or the pink part. So we've got to find two things here and then kind of work it through. Now let's actually look at the rectangle first. Rectangle, we know that the base is 3k minus k, which equals to 2k. Nice, that's like easy as to figure out. The next part is when, see how this point right here, from here to here is the height of the rectangle, but it's also the y value. So if I actually substitute when x is equal to k, y is equal to 2 over x, so y is equal to 2 over k. So this value here, I'm just going to highlight it, this 2 over k is what this y value is, which means the height of the rectangle is 2 over k. So area of the green rectangle is base times height, which is 2 over k times 2k, which equals to 4. All right, so we've just figured out what the green rectangle is. That's actually 4. Next, we've got to figure out what the blue part, the curved, the blue part is. That's the area under the curve, right? So we've got to go 4. I'm going to kind of work, well, it should have worked here, but it's fine. So area under the curve, that's between 3k and k, and the equation is 2 over x dx. This is actually a really easy excellence question, I have to say. It's not that complex, because once you find the blue area, you just go the green rectangle minus the blue area and you're done. So here I've got integral of 2x is 2 ln of x, and that's between 3k and k. I think I know why it's tricky, because I think it's this substitution part of it, but let's see. So we're going to get 2 ln of 3k minus 2 ln of k. That's looking all good. Then we're going to get ln of 3k squared minus ln of k squared. So we're going to get ln of 9k squared minus ln of k squared. I hope, so I know I kind of probably jumped the gun there, but remember that log rules that you guys did in year 12? Like when you have something like a log b, you could have written it as log b squared. That's what's happening here, and that's why I moved that 2 from the front to the top as a power. And then of course 3k squared is 3 squared is 9, k squared is just k squared, and so on. The next log rule that you need to remember is, if you remember, log a minus log b is equal to log a divided by b. So with that in mind, I'm going to do ln of 9k squared divided by k squared, which equals to ln of just 9. So if I look at the area of the blue area, that's just going to be 4. So the how do I write this? Area, shaded area is rectangle minus the little curvy bit. So rectangle is 4 minus ln of 9. But it's asking for, this is one of those stupid tricky questions, but it actually shows right here. The shaded region can be written as a plus b ln c, find ABC. So we've got to actually find ABC, because that's a plus b ln of c. So a is equal to 4, b is equal to -1, and c is equal to 9. But they do say you can accept 4 minus ln of 3 as your final answer, which means grades wise you're looking at excellence for this grade here, correct area under curve with correct integration. So if you get ln of 9, you get a merit. Correct integration gets you an achieved, so that would be somewhere here. You would actually get an achieved. Yeah, I mean, like, look, considering all the other excellence questions that we've done so far, I think this is probably one of the easiest excellence question that we could have done. Yeah, it's just, I think the reason is because they want you to simplify the final answer to a plus b ln of c, and that's more algebra than integration. So it's always good to kind of keep in mind that your algebra needs to be strong as well. Cool, that's it for this question. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.